Alright, so in this video we're going to look over some of the algebra questions from Algebra Revision 1. It's some of the key skills that we'll need throughout our time in Leaving Cert Maths. So let's start with the first one here, and what I'm going to ask myself is there anything in common between the top two numbers here, or the top two terms here? And what I can see straight away is that they both have x in common. So I'm going to factorize that out as it is a common factor, and what I would be left with then is x minus 2 in the bracket on top all over, and the bottom don't have any factors in common, so I can leave that as it is. Then what I have here is I have x minus 2 is the denominator, and it's also multiplying in on the top here. And if it's multiplying in on the top and dividing in on the bottom, that's the same thing as having 1. So those will become 1. So I have x left over on its own. The next one. So for this question, what I need to do is to be able to add fractions together, they must have the same denominator. So the bottom has to be the same in both cases. And how I'm going to do that then is I'm going to change the bottom so that they both have the same terms. So currently the left term here has a plus b. And what I'm going to do is I'm going to multiply that by a minus b. And the other denominator here, the other bottom, I'm going to say that's currently a minus b. And what would I have to multiply it by to get it to have the same denominator as the other? I would have to multiply it by a plus b. And what we see now is they both have the same denominator. But what I need to be careful of here is that if I change the bottom in any way, if I change the denominator in any way, I must change the top by the exact same amount and in the exact same way. So I multiplied the bottom in this case by a minus b. That was the new term that we introduced for ourselves there. So I must then do the same to the top. And that is just ensuring that the value of the fraction itself doesn't change. The same thing's going to happen here. I'm going to have a, and actually what I introduced from here to here was a plus b in this scenario. So I must multiply the top here by a plus b. Now they both have the same denominator, so what I can do is write them as one fraction. So I have a plus b, a minus b. And on top then, if I tidy that out for myself, if I multiply everything out, what I will get in the first case is going to be a multiplied by a, which is a squared, a multiplied by minus b, so that'll give me minus ab. Again, here I'm going to have plus a squared, and then multiplying that in, I'm going to have plus ab. Tidying all that out further, what I will get is I will get a squared, and I actually have a squared plus a squared. So I have two of them if we take a closer look at that. So I actually have a squared and a squared. So I have two of them, so I could write 2a squared. And then I have minus ab plus ab. If I have a minus something and a plus the same amount, they'll actually go to 0. So I've got 2a squared all over then a plus b, a minus b. So that's what we have for the second one. Now, the next scenario here then, so I'm just going to move it down, asks us to look at a fraction within a fraction. So always my first step here would be to actually write that out using different mathematical symbols. So I'm going to use x minus y all over xy. That's the first fraction there. And if it's a fraction here, well, what I could actually say is that's the same thing as saying divided by 5 all over xy. Now, what you might remember from a long time ago is that if you divide by a fraction, you can actually change that to be. So I'm going to change the second one, so flip it and multiply. So you might remember that from way back, even in primary school, you would have seen this, where we flip the second one and we're actually going to change it to multiply. So what we have now is I have x minus y, and I can write that as multiplied by xy all over xy multiplied by 5. And what I can see here then is this xy, and this xy, it's multiplied in on the top and it's multiplied on the bottom. If it's on the bottom, it means divide. So actually, I am doing and undoing. So I'm multiplying and then dividing, or you could think of it as dividing and then multiplying. So you're doing and undoing by the same amount. So what we're actually left with in this scenario is a really nice, neat answer, which is x minus y all over 5. Similar to the last one then, what I can do is separate it out into the two fractions and put another mathematical symbol in between. So we've got p plus q all over 1, and then we're going to have 1 all over 1 1 all over p plus 1 all over q. So what I would actually do first here is tidy up this, because we don't really like to have fractions within the fraction itself here. So what I would do is say, right, let's multiply top and bottom by p in this scenario. So let's see what happens there. So I'm going to have, keeping the first one the same, I'm not changing the first fraction at all. And what I'm going to do is I'm going to multiply this entire fraction, top and bottom, by p. So what I'm going to get there is p on the top, because p by 1 is p. Then I'm going to get 1, because 1 over p by p is going to be just 1. And then I'm going to get plus p all over q. So we're one step closer to having a nicer fraction here. So that's what I'm going to do. And I'm going to then multiply by q, do the exact same thing, but do it for q. So if I do it for q now, what I'm going to have is the first fraction doesn't change. And do keep writing down what doesn't change. Change one fraction at a time. And just see what happens. If I do that, then it's going to be divided by, multiply the top by q. So I'm multiplying the top and the bottom, because I don't want to change the value of the fraction. And then what I'm going to have here then is q plus p on the bottom there, right? Just multiply that by q, and that by q. Everything within the fraction by q. And what that gives me then is I have p plus q all over 1. And what we actually said a moment ago is that when we have divided by a fraction, what we can actually do is flip it and multiply. So we can change this and it will become q plus p all over pq. Okay, so what we have here then is we're going to have p plus q by q plus p. So I'm going to have p plus q and then multiply that by q plus p all over pq then. So that's what we have for that one. And the last one, what we're going to have is again separated out into two fractions. So I've got 4x plus 3 all over x squared minus 49, and then divided by, so I'm just using another mathematical symbol. We could have the fraction or we could have this division here. So divided by 16x minus 9, 16x squared minus 9, that's going to be important, x minus 7. So what I would do here is we could flip it and put the multiplication symbol in, because that would be our any correct step there. So I'm going to do that first. So I'm going to flip it and multiply only the second one. And what we would get is x minus 7 all over 16x squared minus 9. Okay, so now what I would start to do is say, okay, well, there's clearly something going on here. There's some factorizing that can be done. So the top one, do they have anything in common, any common factors? No, so I'm going to keep that unchanged. The bottom one, do they have any common factors? No, but what I can actually see is that that could maybe be rewritten as x squared minus 7 squared. Now that might come in useful in a minute. So then I'm going to have multiply that by x minus 7. all over, and then I have 16x squared minus 9. And again, that's an interesting pair of terms here. I could actually write that as 4x squared, because 16 is 4 squared, x squared, and could be written as x squared like that. And then 3 squared. And if you remember, there's actually a rule that we have where we have a square number take away another square number. That will always factorize down to be a minus b, a plus b. So you should have that taken down somewhere. It's not in any log tables, and it does come up quite a bit. So I would make sure that I know that formula and a little shortcut for myself. So a squared minus b squared, some square number take away another square number. So if we use our colors to keep track of that, my a would be my x in that scenario, my b would be my 7 in that scenario. So I'm going to once again keep everything else that's unchanged exactly the same. Don't touch it, just write it down. What you're not dealing with, keep it the same. And then on the bottom here, what I'm going to get is x minus 7, because I'm following this rule, a minus b, and then it's going to be a plus b, which in our scenario is going to be a was x and b we said was 7. So that's what I have there. Multiply that then by x minus 7. Okay, that's unchanged. I'm not doing anything to it, so I'm going to keep it the same. And I'm going to have, again, a square number take away another square number, my a and my b. So I'm going to have 4x minus 3, 4x plus 3. And what you can see then is we're going to multiply. And how do you multiply fractions? It's top by top, bottom by bottom. So what I'm going to have is 4x plus 3 by x minus 7. All over then x minus 7, x plus 7. And that's going to be multiplied by 4x minus 3, 4x plus 3. And what I can actually see, again, is that rule where if it's multiplied in on the top and the bottom, you're doing and undoing. And again here, so I can also do the same thing with my x minus 7 and x minus 7. So what I actually get left out of that is, well, if I have 4x plus 3 divided by 4x plus 3, that gives me 1. So I would have 1. X minus 7 divided by x minus 7, that's 1. All over x plus 7, 4x minus 3. So what we can say there is 1 by 1 is 1, and we're left with 4 x minus 3, it doesn't matter which way you write it, 4x minus 3, x plus 7. And that's what we got for that one.